So in this video, we're going to be looking at using the trigonometric ratios in order to find the angles of a given right angle triangle. So one of the most important things to remember here is that when you're trying to find the angle of a right angle triangle, you must have two sides of the triangle given to you. Another thing is we can use the inverse of a trigonometric ratio to find the angle. So I'm just going to highlight the most important features of this so that you don't forget, and I would strongly recommend highlighting it yourself in your own notes as well so you don't forget. If we just quickly revisit what the trigonometric ratios are, we know that we have sine, cos, and tan. And for sine we write so, for cos we write ka, and then for tan we write toa. So remembering that sine requires you to have the opposite over hypotenuse, cos requires you to have the adjacent over hypotenuse, and tan will require you to have the opposite over adjacent. So now if we look at the first particular question, so we're asked to find the angle in which for all three examples is represented by theta for the following triangles. So like I mentioned previously, it's really important that you label your triangles. All this does is it eliminates or reduces the chances of you making careless mistakes or just simple errors that can come when you're doing these questions and you don't really think about what each of the lengths are or what they represent. So let's look at the first example. So I've got 10 here. So the side that's 10 we know is my hypotenuse, and that's going to be represented by the letter H. Now, looking at where the reference angle is located, remembering that what I just circled, that's my reference angle. So the side that has the length 6, that's my opposite because it's opposite to the reference angle. So now, if we have a look at which of the ratios that align with the information we've been given an opposite length and we've been given a hypotenuse length. So by process of elimination, I'm going to say that the ratio we're after is sine, which says that sine of theta is equal to the opposite over hypotenuse. So now, filling in the information that I have, I'm going to work backwards in order to find my angle. So I'm going to start with sine of an unknown angle, or theta, is equal to the opposite, which is 6, divided by my hypotenuse, which is 10. So now I mentioned before that we can use the inverse of a ratio. What that means is I'm going to write theta is equal to the inverse of sine, and then we're going to open a bracket and write 6 divided by 10, which is my opposite over hypotenuse. And then having a quick look at the scientific calculator on the screen, so you can see all I have to do now is select shift. If you press the sine button, what actually happens is it'll understand that the command you've asked it to do is to do the inverse of sine. Now it's not going to do that if you just press the sine button. You do need to press shift first. Then I'm going to write that it's 6 divided by 10, and that's going to give me a reference angle of 36.87 degrees. So if I'm going to write a general equation when I'm using sine as my ratio or my trig ratio in order to find a reference angle, I would write theta is equal to the inverse of sine, and then open bracket, opposite over hypotenuse. So that'd be a very general equation anytime you want to use sine in order to find the reference angle. So let's move on to the next example. So again, here I'm going to start by labeling my sides. So 16 happens to be my hypotenuse, 13 happens to be my adjacent, and I know that because the adjacent is the length that has both the right angle and the reference angle there, right in between it. So now, looking at the information I've been given, looks like I'm going to be using cos, because cos does require us to have an adjacent or a hypotenuse in order to find, cos will require us to have an angle, adjacent, and a hypotenuse. Now, we know by filling in our information, so I've got cos of theta is equal to 13 on 16. So obviously I'm trying to find my angle, so I'm going to write the inverse of cos now. So I'm going to write inverse of cos, 13 divided by 16. And again, just looking over at the scientific calculator, so I'm going to do shift, cos, and I'm going to do 13 divided by 16, and that's going to give me a reference angle of 35.66 degrees. So again, if I'm going to write a general equation for using cos to find a reference angle, I would write theta equals to inverse of cos and then adjacent divided by hypotenuse. And again, I'm just going to highlight this because this is pretty important for you to have written down in your notes. And then my last example is going to be a right angle triangle. Now, looking at the information here, the only length I don't have is my hypotenuse. I do have an opposite given to me, and I do have an adjacent given to me. So writing out my general trigonometric ratio, tan of theta is equal to opposite over adjacent. So I'm going to write down the information I have. So tan of theta is equal to my opposite, which happens to be 16, over my adjacent, which is 19. Now, again, we know we're working at our angle, so we're going to be using the inverse of tan. So that would be theta is equal to the inverse of tan 16, or my opposite, divided by my adjacent. So again, on my calculator, I'm going to do the inverse of tan, then 16 divided by 19, and I get an angle of 40.10 degrees. So with all three examples, even though I didn't actually state it in the question, I'm just rounding off to 2 decimal places. Do make sure that when you are doing these questions, you do read what decimal place your answer should be to. So if I'm going to write a generalized equation for tan in order to find my angle, I'm going to write theta is equal to the inverse of tan, and that is opposite over adjacent. And that would be my general equation to find the inverse of tan, or to find the angle when we're using tan. So that's pretty much it in terms of using the trigonometric ratios to find the angles of a right angle triangle. Again, you can see here that the acronym SOHCAHTOA does really come into hand and is really helpful. So do try to come up with a way for you to remember the ratios, because ultimately, if you cannot identify which side is your opposite and which side is your adjacent, it is really going to cause some difficulty when it comes to actually working out the correct angle, because obviously you will have flipped the side lengths and used the wrong ratio. So just keep that in mind. Another thing is, always make sure your calculator is in degrees mode and not in anything else. If you're not sure, just go Shift and press the mode button. And you can see here that it says Math 10, Line 10, Deg and Rad. So if your calculator has a little R up the top, it means it's in the radians mode. You just need to make sure that you're in degrees. So just press 3, and that'll make sure that your calculator is in the degrees mode. And that's it.